the next couple of topics that we're going to meet. In case you haven't already figured it out, almost everything that we've just done can be represented by a triangle in one way or another. So I'm going to go through this lot fairly quickly, and if you want to look back at things, then use the pause button or rewind. So let's have a look at, first of all, a series circuit. From that series circuit, we can produce a phasor diagram. Current is common. The voltage across the resistor is in phase, and the voltage across the inductor is up there. From that, we can get the power supply, as in the supply voltage, and from this, we can produce a triangle. So VR always horizontal, VL up the side, and VS is the result. In this particular triangle, all I've done is I've turned VS so it goes that way. So this is now the phase angle. If we look at this parallel circuit, then here is the supply voltage, which is our reference. The current through the resistor is in phase. The current through the inductor is 90 degrees shifted. And the supply current is the result. And there is phi. Just coming back to this, supply current is coming in here. It splits at this point. Some goes through the resistor, IR, and some goes through the inductor, IL, and they are phase shifted, which is what the diagram shows. This phasor diagram can be reduced down to a triangle. I tend to draw it, I've just seen an error there, apologies, IL. I tend to draw it like this. There's IR, IL is up the side, and there is our result, the supply current, and there is phi. Some people just move IL along there, so we get a triangle that looks like this. These triangles are identical, it's just rotated. Okay, so that was the first bit. So on to my second part. The word civil is used in engineering, in electrical work, as a memory aid. This can help you when you're drawing your phasor diagrams. If we start with this one, this contains a capacitor, so we're going to use the first three letters where C is for capacitance. So current will be common, and if we read the first three letters, just going from left to right, in a capacitor, current comes before voltage. Okay, so that tells us what happens with the voltage across this. So with the resistor, VR is in phase, and when it comes to the capacitor, current comes before voltage. Here's the current, here is the voltage. In a capacitor, current comes before voltage. There's the current, there's the voltage. All of this is going that way. Let's deal with this circuit. So we now have an inductor. It's a series circuit. Let's draw the current. And let's put on the voltages. The voltage across the resistor is in phase. Oops, I want to do current, apologies. There's the voltage across the resistor. And what do we do with the voltage across the capacitor? We're going to use the last three letters. Voltage comes before current in an inductor. So when we're doing phasor diagrams, voltage comes before current in an inductor. That tells me that the voltage across the inductor is going to be there. Okay, so this is a memory aid. Always read left to right. First three letters for a capacitor, second three letters for an inductor. On to my third part. So this is, as the heading suggests, all about triangles. If we consider this very simple circuit, the opposition to current flow, we have resistance, we have reactance, and these two combine to give us impedance. That will go to a triangle, these three quantities. Resistance always horizontal, reactance up the side, and the result is impedance. If we come to this circuit and we deal with the voltages, so we have supply voltage, voltage across the resistor, voltage across the inductor, that will go to a triangle. Horizontal bit is the voltage across the resistor. Vertical bit is the voltage across the inductor. And the result is what is applied to the circuit, the supply voltage. So this is that plus that with a phase shift, which is what that diagram shows. Finally, onto a parallel circuit. In this circuit, the current through the resistor is horizontal. The current through the inductor, doesn't matter which way around you draw this, current through the inductor is there, and the supply current is there. So each of these diagrams, these triangles, have come from the circuit. For every single one of them, we can determine power factor. Power factor is the next topic. Power factor is, in this circuit, it's R over Z. Power factor. In this one, it's VR over VS. And in this one, I'm hoping you've guessed it, power factor is IR over IS. So in any one of these triangles, power factor is the horizontal over the result, the horizontal over the result, the horizontal over the result. And every time, whichever quantity relates to resistance is horizontal.